Chapter 3.1, Solving Linear Systems. From this video, you should learn how to solve a linear system using a graph or a table. Okay, example 1, they give you two linear equations. That's a system of equations. And they want to know the solution. So what you're going to do is you are going to graph them both on the graph, and the point at which they cross is the solution to the equation or the system. And that just means that's a common solution between the two, and that would be why the two lines cross. So I want to put it in slope-intercept form first. So that means I'm going to move the 3x to the other side of the equation, and I get 2y equals 3x plus 8. Then solve for y. So I get y equals 3/2 x plus 4. For this one, I'm going to move the x over, and I get 2y equals negative x minus 8. Divide both sides by 2, and I get y equals negative 1/2 x minus 4. So I'm going to graph the top one in black and the bottom one in pink. The y-intercept for the black line is going to be positive 4, so we're going to go up 4 and put a point. The slope is positive 3 over 2, so we're going to go up 3 and run 2 and put a point there. I run out of room on my graph, so I can do the exact opposite. Down 3, left 2, and put a point there. And then you draw your line. The pink graph, the y-intercept is negative 4, so you're going to go down 4, put a point. Then your slope is negative 1 over 2, so we're going to go down 1, right 2. And since I run out of room, I can go up 1, left 2, and keep going until I cross my other line. And the point at which they both cross is the solution. So the coordinates of that point are negative 4, negative 2. And the solution of the system is x equals negative 4, y equals negative 2. Example 1b, you can try this one on your own, but I'm going to go ahead and do it with you. You need to put it in slope-intercept form, so we're going to move the x over, and we get negative 2y equals negative x plus 4. Divide both sides by negative 2. And you get y equals positive 1/2 x minus 2. For the bottom equation, we're going to do that in pink, so we're going to move that over, and we get y equals negative 3x plus 5. Okay, for the blue line, you're going to do your y-intercept first, so that's going to be negative 2. So we go down 2 on the y-axis, put a point, and our slope is up 1, right 2, up 1, right 2, up 1, right 2. And we draw a line through those points. Then our pink graph, we're going to go up 5, put a point, and then our slope is down 3, right 1, down 3, right 1. And then you'll notice you put a pink dot on top of a blue dot, which that makes your solution right there. Wherever the two lines cross, that's the point that satisfies both equations, so it's the solution to the system, and that's going to be the point 2, negative 1. Okay, we're going to talk about the different type of systems of equations. There's the consistent system, which has at least one solution. There's two types of consistent systems. There's the independent system and the dependent system. An independent system has one solution. And a dependent system has infinitely many solutions. Then you have an inconsistent system, and that has no solution. If you have an inconsistent system, that's parallel lines because they do not cross. So there's no point that they have in common. If you have one solution, those are intersecting lines that just intersect at one point. And then the dependent system, where there's infinitely many solutions, that's coinciding lines. And that means those are lines that you graphed, and they're actually the same line. Alright, so intersecting lines look like this, and you get one solution, and it's where they cross. And that's going to be a consistent independent system. Then coinciding lines are lines where you graph two lines and it's the same line. And that has infinitely many solutions. Then you have parallel lines, and that is where the two lines don't cross. That is an inconsistent system, and there's no solution. Okay, example 4, without graphing, is the system independent, dependent, or consistent? So what we're going to do is put them both in slope-intercept form. So that means I have to move the 2x over, and I get 4y equals 2x plus 6. Divide both sides by 4. And I get y equals 1/2 x plus 3/2. For the second graph, I need to get y by itself, so I'm going to divide both sides by 8. And I get y equals 1/2 x minus 3 halves, because 4 will go into 12 3 times and 4 will go into 8 2 times, so 3 halves. So I get same slope, different y-intercept. If they ever have the same slope and they don't have the same y-intercept, they're not the same line. But parallel lines have the same slope, so these are parallel lines because they have the same slope. And parallel lines you just saw were inconsistent. And that means they have no solution. Alright, let's try. We want to put them both in slope-intercept form, so we're going to move the 2x over, and we get 3y equals negative 2x plus 1. Divide both sides by 3. So y equals negative 2/3 x plus 1/3. On the bottom one, we're going to move the 4x over, and we get y equals negative 4x minus 3. And you don't have to do anything else. So my slopes are different, my y-intercepts are different. These are two different lines, which means they will eventually intersect. So this is going to be an independent, consistent system. Okay, got it? Questions? I want you to graph these two systems on a graph. Find the solution if there is one. And then after you do that, tell whether they're independent, dependent, or inconsistent.